Hi everybody, today we're going to talk about terminating or repeating decimals. Please take out your notes and have a calculator and a pencil handy. Go ahead and pause the video if you need more time, write the heading on the top of your paper, and let's get started. Before determining if a decimal is terminating or repeating, you have to know that a terminating decimal comes to an end. They stop, they do not go on forever. So examples of a terminating decimal are over here on the very far left side. So 1 and 23/100ths is terminating, 3/10ths is terminating, 5/10ths is terminating, and negative 27 and 27/100ths is terminating. And other examples would be whole numbers or integers, like negative 10.0 because it comes to an end, or negative 3. The next number would be a 0.0, so that would come to an end. A repeating decimal does not stop. It goes on forever. So the block of digits that are underneath the bar notation, they repeat. So this would be 1.23. The next set of digits would be 2323. 1/3 is the same as 0.3 forever. So the next digit would be 333. 0.5 forever in your calculator on the very end would have a 6. That's just because your calculator doesn't know how to write the bar. It rounds the end automatically up to a 6 because it comes to an end, so it needed to round that digit up. But truly it is 0.5 forever. Another example is negative 27.27, and the 27 repeats. The bar only goes over the numbers that repeat. It can go over one number, two numbers, multiple numbers. So for an example, if you were to do 4/5 in your calculator, if you wanted to first convert it into tenths, you'd multiply it by 2 and you get 8/10ths, and then write it as a decimal, 0 and 8/10ths if you know your place values. Otherwise, using your calculator, you do 4 divided by 5, and you get 0.8 as well. That comes to an end, so you call that a terminating decimal. Now 1/6 you can do by long division or using your calculator, 0.16 forever. Now in this case, your calculator tells you there's a 7 on the end, but that 7 has been rounded. So the 6 is the actual number that repeats, so you need to put a bar over just the 6. So 0.1 with a bar only over just the 6. Pi is not a terminating or a repeating decimal. It's neither. It doesn't end, but it also doesn't repeat. So when classifying terminating or repeating, pi does not fit. 1/3 fits because when you divide 1 by 3, you get 0.3 forever, which we put over here. 2/3 is 0.6 forever, so you put that bar over the 6. Those are just some examples. There are many out there. So to write a terminating decimal as a reduced fraction, you first have to know your place values. So your place values before the decimal and after the decimal. A mixed number will have numbers before the decimal because it'd be higher than 1. So you might have like 9 and 4/10ths. That would look like this, 9 and 4/10ths. So write as a fraction, you just say the ending place value out loud. In this case, it's the tenths. So to write this, I would write 9 and is your decimal. So 9 would be your whole number, and then I write 4/10ths, 4 over 10. Then you want to reduce when possible, simplify. You keep the 9, and 4/10ths is even, so you can divide it by 2 over 2. You get 9 and 2/5 is a reduced mixed number for 9.4. Here's some other examples. 6 and 9/20ths. If you wanted to first convert this to a place value that you know, like hundredths place value, you could by multiplying 20 by 5 and then 9 by 5. You get 45. Or what you could do is you could take your 6, and since you know it's more than 1, that comes before the and, divide 9 by 20 in your calculator, and you also get 45/100ths. The method that I showed on the right hand side is without a calculator. You could also do it with a calculator. On negative numbers, you just keep the negative and you say the same thing, -2, and then you say this number out loud, 35, and you say hundredths. So I'd write 35 over hundredths has the number 100 in it, so you put it over 100. And then you can reduce it by dividing by 5 over 5. You get -2 and 7/20ths as your reduced fraction. Another easier example, 4/5, you can convert this to tenths by multiplying it by 2, and you get 8/10ths. So you could write it as 0 and 8/10ths. Or if you just did 4 divided by 5 in your calculator, you'd also get 8/10ths. Repeating decimals are much more fun. To set a repeating decimal as a fraction, you first have to set the decimal that repeats equal to a variable. I like to use the letter n to represent the number, and then you multiply each side to clear your repeating number. So whatever number is in your bar, you have to multiply by that denominator of 10 in order to move that decimal past the repeating line. Then you subtract 1 from each side, squiggle solve for n, and simplify if possible. It sounds easy, and once we do a few examples, I hope that you get the hang of it. If you need more help, please continue to practice. Here we go. You definitely need to have a piece of paper out, and whenever you have negatives, you just ignore them until the end. So please write this problem down, pause the video. All right, so to get started, the number that repeats is 0.3 forever. So I'm just going to let n equal 0.3 forever. I define my variable over to the right-hand side, and then I can ignore it for now, and I set up a squiggle problem. So this is going to be a squiggle problem where I solve for my variable. Now before I can do anything, I have to determine how many place values I need to move to clear the numbers in my bar. I need to move one place value, so I'm going to multiply each side by 10. When I multiply by 10 on the left side, 10 times n is 10n. When I multiply 0.3 forever times 10, it moves that decimal in one place value to the right, so I get 3.3 forever. What you want to do is you want to make sure that you get the number that repeats on the outside here. Once you do that, your squiggle problem will work. So now I'm going to subtract an n from both sides, but when I write it on the number side, I'm going to write it as what I let n to be. So up here I let n be 0.3 forever, so I'm going to copy that down. Now when you see I do that, 10n minus 1n, 10 minus 1 gets me 9n, and 3.3 forever minus 0.3 forever, I'll just get 3. So I cleared out my bar decimal that repeated. Now I can just solve for n by dividing by 9 on both sides to isolate my variable. N is equal to 3/9. Then you always want to make sure you simplify your fraction when you can. And I get 1/3. Now this isn't quite done yet because it was a negative, so I need to make sure I put the negative back on. N is equal to negative 1/3. So you can check in your calculator to make sure you did it correctly. If you divide 1 by 3, you'll get 0.3 forever. So negative 1/3 is equal to negative 0.3 forever. Now I'd like you to write this problem down and then pause. Now you need to first determine what you're going to let n equal to. So you want to equal to the decimal that repeats. Let's go ahead and pause the video and see if you can do this on your own. So the number that repeats is 0.27 forever, so I wanted to put that under bar notation. Now, what number are you going to multiply by in order to clear out your bar notation? Pause the video and see if you can do the next. Since you need to move the decimal 2 spots to get out all the numbers under the bar, you need to multiply by a number 1 that has 2 zeros after it. So you need to multiply by 100 on both sides. So once you do that, you'll get 100n is equal to 27 point, but then that decimal keeps repeating forever, so I need to make sure I have that repeating decimal. Now do you remember the next step? I want to subtract 1n from both sides, but on the right side I'm going to use the number of 0.27 forever. Pause the video and see if you can do the math on your own. So when you did that, 100n minus 1n equals 99n, and 27.27 forever minus 0.27 forever clears out your repeating decimals, brings you down with 27. Now to isolate your variable, you divide both sides by whatever's next to your letter, and so you get n is equal to 27/99. And they're both divisible by 3, so I'm going to go ahead and divide them by 3 over 3. I get my final answer of n is equal to 3 over, sorry, they're both divisible by 9. There we go. 3 over 11. Now go ahead and check it in your calculator, and you'll see in your calculator it says 0.272727, continued on. If a calculator could write bar notation, I would know that I got it correct, because that is equivalent. Let's do the next example, a little bit harder. So go ahead and write this example down. I let n equal 10.105. I'm going to show you that this is going to be a mixed number, but we can still do it. Go ahead and pause the video and see if you can get started just by clearing out your fraction. Now in this case, I need to move the decimal 3 place values in order to clear out what is underneath my bar. 1, 2, 3. So 1 followed by 3 zeros. I multiply both sides by 1,000. So I get 1,000n is equal to 10, 105, but then that bar is still over the 105, and it repeats that same sequence. So now when I subtract an n, I'm not just subtracting the bar because I let n be 10.105. So I need to subtract 10.105 forever. You want to make sure when you're subtracting decimals that you line them up. Go ahead and pause the video and see what you get. So the left side in this case is the easiest. 1,000 minus 1 gets you 999. On the right side, the bars cancel out. Decimal comes straight down. 5 minus 0, 10 minus 1, 0 minus 0, and 10. So I get 999n is equal to 10,095. So divide both sides by whatever's next to your variable. And since your top number is bigger than your bottom number, you know you're going to have a mixed number. So I'd like you to head to your calculator and type in 10,095 divided by 999. And your calculator would tell you that it's 10.105 forever, which is what we want. But I need to get to that fractional number. So in order to do that, if you have a scientific calculator, you can use your ABC button. It looks like this. But on a MCA test, you're not going to have that, so I'm going to show you the way around it. So if you do not have the ABC button, you can think 10,095 divided by 999 is 10 and something. So 10 groups of 999. So I take 999 times 10, and you get a product of 9,990. I take that away from my numerator, so I subtract those two numbers, and I get an answer of 105. Now that's not reduced. I can reduce that by dividing it by I divide both by 3 over 3. I get 10. I'll get 333 on the bottom. And on the top, I get 35. So my reduced mixed number is 10 and 35 over 333. If you do have an ABC button, a faster way to do this is by taking your numerator, 10,095, and then hitting your ABC button, and then your denominator of 999, and it'll spit out your mixed number right away. You'll have a 10, and then you have a little unit thing that looks like that, and then 35 fraction bar 333, and then you need to make sure you write it as a mixed number, 10 units, and 35 out of 333 is equivalent to this decimal. Great job. Thanks for being here. Make sure you ask for help. Make sure you practice this repeating decimals. It's not something that comes easy, but once you get in the habit and you know the steps, it's much easier. So keep practicing. Thanks for being here, and I appreciate your time.